So very good evening, everybody. So let's start with your NATing practical today. So I'll be going to give you first enterprise level with respect to routing, how we'll be going to do the NATing, which will give you the understanding. If you lose the touch on your NATing concept or any networking topics, I'll try to cover your basic fundamental first, and then we'll go and we'll be going to touch the firewall concept. Okay. So it's not like only you'll be going to study security devices and the basic fundamental. If you don't understand or if you don't justify, then it will be problem. So let's consider here, we'll be going to have this router will be acting as your ISP. Consider your ISP have give you one public IP. So here this link will be your public address. Your router will be acting as a gateway here. Router will be acting gateway, and here we'll be going to do the network translation for your this hosts. Okay. So we'll be going to use couple of networks here. So let's consider here we'll be using 100.1.1.0/24 network we'll be using. So this is the network what you are having. Let's say this is your router 1. So we'll use 1.1 here and 1.2 on your ISP size we'll use. Okay. This will be acting as your ISP. So let's make him ISP here. This router, this interface, let's consider you'll be using 192.168.10.10, which is /24, which will be acting as a default gateway for this two host. This network will be your 192.168.10.1. And he will be another system will be 10.2. Call him a host 1. Call another host is host 2. Okay. So increase the text size. Is it okay? Okay. Let's put it in this way so you will be able to observe. Okay. Now let's first assign the IP addresses to these laptops. 192.168.10.1/24. 192.168.10.10 will be your default gateway. Copy default gateway, which will be needed for another host here. Done. Now let's configure your router's interface here, which is gig 0/0. So we'll just configure here with 10.10 and another interface, which is gig 0/1, which will be your 100.1.1.1, which is /24 will be going to use. So let's call it as a /24 here. Now this interface of your another router, which is ISP, will be going to configured with 100.1.1.2/24. Let's bring it up. Let's fast forward this. Now let's check the connectivity here. So on this ISP router, we'll be going to do, let's say, do debug, which will give us the information. And let's ping hundred dot one dot one dot two. You'll have the reachability or not? Can you guys tell me why you're not having the reachability here? Is your request is reaching to the server? Is your router is receiving this request? Yes. See, when this system will be going to send a request, it will be going to submit this request to the default gateway. System will be going to check the network bits. It will understand you are trying to reach out to the different networks. So this request should be submitted to the default gateway. Default gateway will be going to look for the network information. So this network, this router have the information about this network, which is 100.1.1.1, which is directly connected network. So which interface it will be going to submit, it is submitting on gig 0/1. But this router's interface, like this router's routing table, if you check, there will be no information about this particular network. So this router is receiving the request, but you will be not able to send the response back. So you can verify this information here. What you are passing information here? You're having source IP, you're having destination IP, you're having protocol information, which is 1, an ICMP type message which you are sending, that is echo request. So it is echo request, means type 8. So this is what you are sharing here. When this request go here, this system respond to this. So here source IP will be 1.2 and destination IP will be 10.1. So respond is going, but where to go, which interface to be selected, that information is not available on ISP router. So if you check the routing table, you don't have any information about the network, right? 192 network information is not available. And though that is your private network, so we need to do the translation. So first of all, let me change the name. Should one default route here, which is pointing toward your another interface, which is 1.1.1.1. And now check if you respond or not. And you're having the reachability now, correct? So if you check now, what is your address? You are using 192.168, which is a private address. And as per RFC document 1918, you will be not able to use this address over the internet. This is a non-routable IP. So you need to have the translation here. So let's understand how many ways you can do translation on router, because similar concept we'll be using on ASA router. So you need to understand with if you relate both the terms, you will be able to follow quickly. So see here how we'll be doing this. Now on your router, which is your default gateway here, this router will be going to do the NATing. NATing can be do in a two-way, static way and dynamic way. Correct? Now static NAT means, see, NATing is called address translation, right? Network address translation. So this network address translation can be done in a two-way, static way and dynamic way. Static way means we'll be going to map one IP with public IP. So you need to map these IP addresses one-on-one. And understand, guys, you can map one IP, let's call one private IP, to one public IP only. So as per rule only you can do this. So it is called NAT, network address translation. One-on-one IP will be able to map. So if you are having one IP, one public IP, currently you're having this public address. So this also can be done in two ways. You can have dedicated static IP. In last session we discussed, right? If you'll be having any dedicated website or server, or you want to have that a separate identity which should not change and which will be able to communicate over any point of the world with that specific IP. So you can you can purchase one static IP from ISP, or you already have the IP which you have received from the ISP. So you might be saying, why should I go for the static IP? Yes, you can use this IP as your identity, and you can have a static IP as your communication only. So you can give the separate identity also, and you can use your exit interface of your router, which is your public address given by the ISP. So very first thing we'll do with a static mapping, one private address will map with the public address, and then we'll go with PAT, where your both system will be able to communicate, but this both system will have the identity which is provided by your ISP. Okay. And then we'll go for your dynamic NATing here. So dynamic NAT PAT will be here done. So let's see how we'll be going to do this. So consider you're having IP, which is you have one static IP now. So let's say you purchase one static IP. And static IP which you got, that is, let's say 150.1.1.1.1. Now this address you are having. Now you want to use this as an identity when you will be going out. But as we discussed, static IP can be mapped to one public address only. Either your host 1 can be mapped or either your host 2 can be mapped. Both cannot be mapped to the one IP. So this is called static NAT. So once you will be going to do this, see how we'll be going to do. So let's map it first and then we'll verify. This is your default gateway. So let's call it a default gateway. Now, first you have to specify which address you will be going to translate. So let's say your interface gig0/0 will be using IP NAT, and inside and outside you have to specify it. What it will be specifying, which source will be going to translate. So inside network, inside interface for address translation, and outside interface for network translation. Means here your incoming traffic will be translated and it will go out, and when traffic will come back out to in. So this flow you have to specify. That's why we will be going to specify here. So let me just only remove here. So we'll be specifying it is as an inside, and let's go to the other interface, which is gig0/1, specify it as IP NAT outside. So once you specified your interfaces, you are done here. Now we can go and we can say IP NAT and see which you can go. You have already used inside and outside, which specified your interfaces. Now this will use inside, because which address translation you are doing? We are doing inside network translation, our private IP translation, which is in this network. So inside translation, if you do, now you will be having option which is source. So it is inside source translation we are doing, and then you will be having option as a list and static. List is for your dynamic, because you will be having list of public address. So it will be going and specifying it as a list, and static will be for one-on-one mapping. So currently we are doing what? Static mapping. So let's do the static mapping here. Call static. Then you will be having option to specify a specific address. Okay. So you'll be specifying address which you want to use. So we have decided to use 150.1.1.1.1. This is my public IP. So we have already got this address. So we'll be using a static IP. Now for which host? Now read this completely. It is saying what? Inside local address. For which host I want to use this? So either I want to use this address to translate and have the communication with the identity of 150.1.1.1, or I will be using host 2 address. So let's go with the host 1. You can say host 192.168.10.1. I have to go, and what will be my global address? My global address will be 150.1.1.1.1. So far what we have discussed already, if you ping, what was your identity? 192.168.10.1. And now let's check. Do you have anything? No. To verify NAT, do show NAT translation. There is do show IP NAT translation. So here you will be able to see the NAT translation is visible, that your inside local address will be 10.1, which is 192.168 private address, and global will be 150.1.1. Now if you ping, you will have the reachability. Now verify what is your identity on ISP side. Now on ISP side, your identity changed from 192 to 150.1.1.1. But what if my other system ping? What if this system ping to the let's ping what address we use? 101. So 101.1.2. See, you are having reachability, but identity is private, which is not translated here, which is like this. Okay, so this supposed to be get translated into public, but when you are having those number of public address available in static, only one-on-one mapping can be done. Okay, so let's now understand how we will be going to allow to have the communication with the ISP for both the host. This is the static way what you did. Now let's do the dynamic way. So for that, let's remove this NAT configuration. So let's say do show run section, just call NAT, not INAT, and say no. We need this configuration, so we'll not remove this configuration from router. We only need this configuration, so we'll just say with this. So say no to this and done. Now, in order to have your dynamic IP, you need to have three things. Very first thing you need that is the pool of address. So which is public, private, any address pool you required. So let's call it address pool you required. Then you have to specify with the ACL which network you want to permit, because on one router there will be multiple interfaces are there, right? So which network you want to allow and how the translation done, that ACL you have to specify. And lastly, we'll be going with the NATing configuration. Correct? So these are a requirement what we are having with the NATing here. So if you go to the router, let's first say IP NAT and give question mark. Can you see your pool? This is to create the NAT pool. So call pool, and then it is asking for the name for this pool. So I'll just call it like public for public address. So let's call public IP only. Then give question mark. What did it say? Starting IP. Let's consider you are having 150.1.1.1.1 to 150.1.1.1.10. And you have to specify the net mask. What is the net mask you are using? Net mask dot 255 to 55 to 55.0 and done. So here your pool is created. Now you can use access list. Let's call access list 10. Permit the network which we want to permit 192.168. You can use directly network or you can use any. Both is fine. So you can use specifying that 192.168.10.0 network. Okay. Then wildcard you have to specify, or let's say any share. Correct? And after this, you have to go for NAT configuration. So IP NAT inside source, and then you have to specify the list, because you are having what? List of pool or list of IP. You're having it. Now you have to specify the word or number, whether you are going for access list name mode or number mode. So we have used access list, which is 10. Out of this list, access list 10, I'll be going to permit it. And the pool and pool name we have used, that is what? Public underscore IP. Let's verify that name first again. Public underscore IP. Correct. And that's it. If I go with overload, it will do patting, dynamic pat, but which we don't want to do right now. I want to do only for NAT. And now if you see do show IP NAT translation, there is no information available, right? And let's ping both the devices for, let's say, iPhone N20, and here we'll do the normal ping. And now verify. What is your identity? 121212, which is public address. See, can you see 121212? Yes, this is the translation happening. Now both the system are pinging to the ISP with the public address, which is from the pool. And if you verify this information at this router, your table will be having the information. So network address translation information, if you see, you will be having protocol ICMP inside IP, which is globally you are having, that is 150. See, by default, your packet tracer will be going to show the port numbers here. Okay, packet tracer show many information as sample information, or you can say helpful information to understand. But when we go to the ASA, this information will only be visible with couple of commands, because there you are doing patting. So with patting, this is visible. With static NAT will be not considered this. Okay. But here is your internal IPs and here is your external IPs. Okay. So this is how the communication happening. Okay. So this is one way to do this with pool. But along with pool, now let's do a different thing. So let's say no to this and let's call it network part. Doing what? Inside address. Source will be list. List is 10. And see here. Interface gig 0/1. And overload also I'll do, just to show you one thing now. If I do this, see here, I do have the list. In list, which address I'm having? 150.1.1.1.2, 150.1.1.10. But I have specified the interface here. Now, what does this interface mean? Let's verify first. Verify, can you ping? Yes. What is your identity here? Oh, identity change. 150.network change to what? 100.network. And which is this address? Address of this interface, gig 0/1. But we specified the pool, right? No. I told you, right? One way you can do this, that is from the pool. A company can have the set of pools. From that pool, you can do the translation. But you also can use your exit interface. This is not preferred one, or which is not company use this, but this is also one of the way you can communicate with the ISP. Now, like what usually our home router do. Home router will be using this interfaces, which is having public address. This is getting translated for our internal devices. So you will be having different mobile. Let's say every house, at least 4 mobile, 2-3 laptops. So everybody will be going to use the identity of this interface, which is given by the ISP. Okay. And this is the translation is happening when you go for interface one. Okay. So this is one way to do this. Now we understood here static NAT, dynamic NAT, and dynamic PAT. Okay. With pool and with interface. This is what we have discussed. Now let's go to the ASA and understand the same with respect to your firewall now. Because many things we will be able to correlate here. Now let's first get the console for all the devices here. So get inside router here. DMZ, ASA. This will be your management PC. Internet PC also you can use here to monitor. Okay, so okay. So let these devices come up. Meanwhile, okay. Meanwhile, I'll try one thing. I need to check. Can we get IP HTTP server HTTP? Correct. I'm doing why it is not accepted. Okay, so HTTP is not working here. Cool. Then we'll do it on inside router only. So let's get all the device console here. All interface will be by default down, so we need to bring every interface here. Do show IP interface brief. This command will not work on ASA, so it will throw error. The rest all is fine. Everywhere we are having gig0/1, so let's call interface gig0/1. No shut. Bring all the device. Now we'll do configuration on ASA. ASA, we need to go and say do show interface IP brief. Do is not required. That's okay. So interfaces are up here. All the AC interfaces is up, so good. Then let's verify with the other device as well. So do show IP interface brief. We wanted one interface which is up, but let's quickly verify with the other routers. Up, it was down. Now it is up. Outside router up. Outside router 1 should be up. Good. Now, see, we have configured here on outside router 1. So let me color outside router. All outside device will be coloring in red. Low security level. So we'll be going to treat them as a danger. And let's call ASA, which will be filtering. So we'll be going with blue. And all inside you can put it green, but we are not putting any other colors. I just need to identify who's my ASA and who's my outside routers. That's it. Now, let's first verify the reachability from router 1 to the outside router. And IP will be 11.1.1.125. And reachability is there. So you guys have already, so please repeat the second method for once. Praveen, which method you are asking? Yes, Praveen. Which method? Second method. Sorry, I didn't saw your message. Tell me which method you want. The default gateway one. Yes, yes, sure. See here. Consider you're having a pool, but now the pool is mandatory, or let's say if you go without pool, it will not accept only IP NAT. Then if you will be going to convert inside source with static. So static, it will not give you the option for your interfaces. So you have to go with a list, and list name mode, a number mode you have to get. Now inside that pool, so let me change the pool only. Okay, I can change the pool and put the this address only, which is my interface one. What I did, I use the same pool and go with the interface here. This is what I done. So I can do one thing. Let's do show run section, or just include pool. So this pool I'll remove, and I'll create the pool with one address, which is my interface one. So IP NAT pool, and I'll call interface IP. And IP is what? 100.1.1.1. Correct? And then you have to use ending address, which will be the same 100.1.1.1. Then net mask and subnet you have to specify. This is what you have created the pool. Now, once you created this pool, now you have to apply. So let's say IP NAT ACL you can use because ACL is required. So we'll be saying do show run section access list. So access list 10 permit any we have already given. So we'll be using the same ACL. NAT inside source. We are going with dynamic and then we'll be specifying what? Your ACL number, which is 10. And then you will be going with interface, which is your exit interface, which you have to specify because router need to know, right, which interface you are talking about. We are talking about gig 0/1. And that's it. Here, if you execute this command will execute and this will do patting in your packet tracer. But in real life, you have to go with the overload also. So it will do the patting. Overload means port overloaded, not one port you will use. Port will be multiple use for single address. So overload you have to do. So once you do this, you can verify this with do show IP NAT translation. So currently it is not there because there is no transaction happening. So once you generate the traffic, the translation will happen here. So dynamic translation, why it is not visible? Because static, you know which is source and which is destination. This is fixed. So you will be able to see this information. Dynamic, it's a pool. So from that pool, which address you will be using, that is not fixed. So if it is not fixed, until and unless traffic generated, the available IP will be get selected from the pool, and that IP will be going to map with the port number, and then it will go and have the communication outside. This is what the communication will do. So here is your interface IP, which is for everybody. Like here we are only generated traffic with who? 10.1. So we can do the same thing. We can generate traffic from both the laptop and you can verify. Now see the traffic here, what we generated for who? 10.2 also and 1 also. Both are having the same public address, only port number is different. And this is what your interface you will be able to use. Okay, so now with router now, so let's first take your HTTP configuration. Like we have already configured HTTP in last session only. So just to verify, I'll just showcase the thing. Do show run section HTTP. So this is the configuration. HTTP server authentication, which you will be going to do locally. And this is for your HTTPS secured server, if you will be going to do for secured server. So once this is done, now we can verify here you are reachable. So we can get access of this here. So to get this access, let me first, this PC is not working. So I'll take this PC access, which is client PC. This is node 12 and this is your MGMT. It's fine. Test 1, 2, 3. Done. Now see. This is your client PC here. From this PC, I'll be going to get access of router 1 here. Okay. And from that router, we'll be going to observe couple of things. So first of all, you need to have the IP. So verify the IP here. Okay. IP is already there, 10.1.1.5. Verify the reachability then directly. Let's verify reachability 11.111. What is IP? 11.1.1.25. 125 only, correct? 1.1.125. And we are reachable, correct? So it's good. So let's go to the browser. Eleven dot one dot one dot five. And it is asking for username. So username is admin and password is CCI. So let's verify that as well on router 1. So just reduce little bit transparency here, which is too much transparent. If you want to see topology in background, let me know. So I'll adjust the transparency here. Do show run set include user. So username is admin and password is CCI. So good. So let's do and provide this information here. CCI. So this is how you took the graphical access of this router here. Now go to the privilege mode. And once you go to the privilege mode, you will be able to see now command section here and which you pass the command. So all other information you also pass, like normal command if you want to pass, like show IP interface brief. It will give you the information about interface. But I want to see the specific information for show IP HTTP server history. Who is accessing server? This information I want to see. So currently there is no patting done. So 10.1.1.5, this network is accessing here. So 5 means currently who is accessing this system from which we are already taking the access. Correct? On port number 80. If you see here, it is on port number 80 means we are talking about HTTP request. This is the well-known port number. This is port from system. This is 49,000 means it is dynamic one. Correct? So we are verifying it on this PC. Now if you ping it from router 1, router 1 should be reflected. And this entry stay there for a very short period of time. So we have to quickly get this information here. Again, it's from 5. So let me just generate traffic for longer period. Repeat, let's say 100. No, it's already done. Now see 11.11.5. Go more than. So still it's not showing here. So we should see here, which is 10.1.1.125 here. So let me see on ASA. Show run policy. ICMP is not here. Now, have you guys study one command which is fix up ICMP? Fix up protocol ICMP. Have you studied this command? No?
No.
Okay, see then, good. So which will help you. See, by default, you will be not having this command. Like by default, your policy here, which is this policy map will be going to map the protocol which will be going to put under inspection. So inspection, if you see here, ICMP is not there. So this you can add two ways by default, like you can create the ACL and you can add policies here. So as we go forward, we'll be going to add so many protocols here. So we'll be doing this many times later also, but for now, there is one command for specifically for your ICMP. This traffic, which will not currently under inspection. So you will be going to use command call fix up protocol and see what all protocol you can fix. These all are protocol you can put it under inspection. So currently I want to put only ICMP. And now if you see show run policy map, can you see now ICMP is here? And previously it was not there. See, correct? So that's why it is not under inspection. So let's try again here. And if you check it on your ASA, one more thing I'll show you. To see the translation, so we can use command show xlate, show NAT details. This three commands will be going to verify all the things. So let me generate traffic again and we'll run these commands here. Because there is no translation happening, so this will be not visible here. So we will be going to do natting and then we'll verify. Because there is no configuration is done, so it is not showing here. But we should see this one who's accessing this server. That is what I'm expecting, but this is not reflecting here. But this is supposed to be reflect here. So we'll do that, fix up that again. But so far now, let's see how to do the configuration here. Now consider you're having here, same, we will be going to have one public address. So consider you will be using one public address here. Okay, so 150.1.1.1. Okay, this will be wiped out. So we'll use this one. 151.1.1.1.1, which is your public address. This address will use for the identification of one device. Okay. Now, when you will be going to send any request, right? What happened? You will be going to send request. ACL you guys have done, right? Yes, others, Rakesh, admin. Who's this admin? Can you change your name? Palmer, Praveen, Viraj. Have you guys done ACL with it? Yes. Okay, good then. So you guys know, right, how ICMP request will go and how ICMP echo reply will come. So you have to permit reply here, correct? So let's see now. Along with this, now we have already understood this. See, two-way we can configure your NAT here. In ASA, you can do the normal NAT, what we have done on your packet tracer, right? Similar way we can use the NAT to configure here. But what it is preferred, that is the object one, which will also help you in your FTD when you will be going to take the backups and all. Network object will help you to configure, like make it easy configuration, and which will be more dynamic, versatile to use. So there are many uses are there. Like, have you guys used any trap objects in redundancy, like FHRP, when you will be using? Have you used any objects there in CCNA or NP? Let's say you are having two interfaces, and one interface, if it is going down, then you will be going to switch your traffic to the another interface. So you will be going to judge the other side of your router's interface. If it is going down, yes, virtual gateway, but virtual gateway is a, see, let me showcase here what I'm trying to say, which will help you here. Now consider you are having a network which is like this.
No, WhatsApp call.
Yes, Rakesh, you're saying something? Yes, Rakesh. Now consider here. This Rakesh, your voice is not audible clearly.
Yeah.
See, consider now this is your host here, and you want to have the communication from this, and where you have already now in HSRP, what you do in HSRP, you have generated virtual IP and virtual MAC address for this interface. This is your own domain. This gig0/0 is domain what you want to keep the redundancy. Here failover you want to, like here you are managing the failover. So if your failover is happening on this gig0/0, then you will be able to follow. But what if your failover is happening on this interface? Means as per your configuration, you will be having commands. If here you will be going to failover, go to another site, reducing your priority, go here, and you will be having prevention on. So that is what your configuration here, right? But how you will be going to tackle when your other side of router is going down? How you will be going to have the effect here? See, when your other side of router is going down, what is the behavior? A behavior will be, consider this link is down. Okay, here already it's down, no? So consider this one only. See, here this link is down. Now, as per your configuration, this is your priority router. So let's say this is my backup and this is my active one. So this was my active one. Active. Now, as per your configuration, what you will be saying, the priority of this router will be 255 and here we are having 240. Your traffic will go here and it will drop. And it will not switch to this link because this link is up. This link is still up. If this link is not going down, so this will not switch over. So your prevention is depend on this link's uptime. So if you don't know the status of other end, so you'll be using a trap. So I'll just show you the configuration. I'll not configure the lab. If you want to see, you can just let me know in next session or any other session. I'll just show you that. But if you want to see what you do on router also, see interface gig0/, what was the interface? Gig0/0. And you do the configuration, right? IP. Then you will be going with, let's say, it's a standby IP or any say group. Then you will be going with the track. I'm not providing that number and all. I'm just showing the configuration. Gig0/0. And I'm tracking which object? So this is your track object. You will be using a track gig0/0 interface. And if this interface goes down, it will be going to constantly monitor on the same router the other interface and will be verifying it under which interface? Under gig0/0 interface. So here you will be going to take decision if your other side of your router's interface, if it is going down. So you will be going to switch this network by changing your priority. So as soon as this go down, and consider your priority was 255 here, by default it will reduce by 10, or you can set that value. So let's say you are having 255 here and here you are having 250. So automatically this system will be going to reduce its own priority by 10. So it will become 245. And then highest priority will be becoming your active again. And your traffic will move from this interface. So this is how you use the tracking object with routers. Now, similar way, we want to use objects for multiple reasons. But for now, with NAT, how we'll be going to use it? See. So first, how to configure without NAT? I'll just show you the syntax, but we'll be not using syntax that because we want to have a practice in your lab perspective also, because in lab also you should be using only network objects. So let me just give you. See this. Didn't copy it only. This is your syntax. So this is what your syntax is. for your normal NATing. So we don't need to use this. So we'll use the network object. Now, how to create network object? See, we'll directly practically do this, so you will enjoy more. So to create object, command is very simple. It's a object, and for what? It's a network object. Now, any name you can give here. So let's call it a public address, public, and hit enter. Now you will be entering into the mode which is called object configuration mode. So at this interface mode, you will be going to add the specification for your group. So this object, what all things you can do? See, you can specify the FQDN, fully qualified domain information. If you're having DNS information configured, you can go for this FQDN information. If you want to have a single IP, you will be going with host. If you will be having a range of IP, you will be going with a range. And if you are going to do for whole one subnet, let's say whole /8, 16 or 24 network, you will be going with subnet. So these are the things we'll be going to use and specify. So let's use one by one. Let's consider we already took IP, which is 150.1.1.1 public address here. And we'll be going to now do network translation. So let's first create this information. Let's say host. And I'll be going to specify my address. So for which host I want to have the communication. So here you can specify which is this public address. What is my public address? 150.1.1.1.1. Correct? And that's it. No subnet is required. Just hit enter, done. Exit out. Now we'll go with another thing. Object, network, and let's call this private. Correct? And now you can say host. Currently we are doing for static. So 1 IP only we are having. So for which host we want to do the configuration, like conversion is, so let's call, we are doing it for 10.1.1.125. 10.1.1.125 router 1. Now let's verify the information here. So you can say show, call a run, or let's say show, not object group, show run objects. So here you will be going to get the object related information with this command. Now, along with this, now you have to see if I want to clear the object. So you can use the command clear configure object. This command will clear all the objects. So verify now, show run object. You don't have any object. So all objects will be cleared here. Along with that, let's say a dummy command I'll be going to specify it. Let me try this if it is accepting. No. So to clear IP NAT, so you will be using clear. Same command will be using clear configure NAT to clear all the NAT configuration. This command which I wanted to show, once we'll configure, we need to use this command multiple times. So this two command to clear the configuration object and NATing configuration, correct? So whatever you configure, this what you can create and clear. So we understood how to create the object, how to clear the object, correct? Now let's do the configuration. So now statically we'll be able to do, so call this now. We want to create object network and call this address, setting that, let's use private -IP, private address, which we want to give address for 10. let's use for host address, which is 10.1.1.5. I can create host here only. Inside this, again, I can create as you can do it on router. But for your better understanding, I'm going out and using again object network public IP. And public IP we have used, that is 150.1.1.1. Now, again, NAT can be done in two ways. NAT can be done within your object also, and that can be done outside your object also. Okay, two way you can do the NAT. What is preferred? You can use inside object, which will be helpful, but I'll show you both the way to do this. So let's first do it from outside. Now, how to verify the NAT details? You can say show run NAT, because we have not configured it, so it will be not visible. So let's first configure the NAT and then we'll understand. So wherever you are using NAT, normally on router, you don't have any other special commands, but here on ASA, you have to use inside, outside, because you are doing translation for inside network to an outside network. So you have to specify inside to outside. Okay, so you have to use same syntax, network in bracket inside outside. Then you have to specify the source information, and then you will be going to state how you will be going to do this, statically or dynamically. So let's say static, and you have to specify the object name which you created. So what object will be using? So first we'll be using, let's say, private, and then you will be using public. So this syntax which you have to follow while you are configuring NAT. So let's do this here, the same configuration. So what we are doing, NAT, see here, inside, outside. Options are what? Source, NAT position rule, which we have not done it yet. So we'll just go with the source. Then you will be having what? Static and dynamic. So currently we are doing static NAT, so static. Then you can specify here the object name or any, you guys know how and what it will do. So we'll go with what? Specify object or object group name for the real source. Real source means from inside, what will be the source? And later it will show outside source, which will the real source after translation. So then you have to specify the public address there. So currently what you have to specify? Private. So do not make any mistake here. So you have to use the same object name which we have configured. So call private. Now see what it is asking. Specify the object name for mapped source, means after mapping, what will be the source? So public one. So we'll call the public one. So let's call this public IP. And done. Hit enter now. Now see, show run NAT. This is the NAT configuration currently what we are having. Correct? But it's not having any clear idea which IP, what network. No, whatever command you have given, that will be shown here with this command, because it's a running configuration you are fetching. After that, let's say show NAT. Show NAT will be only showing the same information what you have done. Where is inside, where is outside, and how many translation you have done. That hit count should be increased, but this will be showing here hit count and the inside and outside network information only. So you'll be not having any clear idea about here as well. This is only to understand what is going on. But if you want to see more information about this, so you'll be using detail. And now you'll be able to see what is happening. This is a manual NAT. How? Manual NAT. Then inside to outside, you are going with this object, which is private IP to public IP. Translation hit also you can see here, but who is your source? Origin will be 10.1.1.5 and /32. So here just need to understand the network. This is port number. Now here 150.1.1.1 on port number 32. So let's see your translation table. So you have to use xlate for X for translation. So translate table. So show translate. And now here you will be able to see inside this network to outside this network you have mapped. And you'll be able to see the flags here, which is S and T. S for what? Static. And T for what? Twice NAT. This is also called twice NAT because it will be doing translation twice. One for going, one for coming back, twice. So it is considered as twice map. Okay. Now let's verify. Is it true? So from this system only we'll be generating. So we'll be having this information here. So far, if you see, what is your identity? 10.10.10.15. Now, if you specify, it's good. It went. So we can start from over. Remove this with privilege 15 with show IP history. Now see what is your identity. 150.1.1.1. So your translation is done, correct? So this is what you will be able to see. Now from this laptop also you can generate, like from this host, you can generate the traffic and you can verify this here with command show server history. Now who's accessing server? 150.1.1.1. You can execute again to verify. See? So this is your mapped. Now, once you mapped, what all changes happening on ASA? Let's verify. So what we have in show NAT detail table. See, the hit is 13 now. It's increased. And now show xlate table. You'll be able to see the entry timed out is okay. So let me generate a traffic which is for more amount of time. Now, here is your identity and now verify here. So you are having conversion from 10.1.1.5 to 150.1.1.1 here. Okay. Along with this, let's observe couple of things. Show connection table. So in your connection table, probably you guys have already discussed the connection table, right? Yes, no? Yes, Adarsh, Viraj, Rakesh. So see, your connection table is for ICMP. You will be having, this is your idle time. Now we'll verify a TCP connection here. Let's just refresh this. See, for TCP now what? You will be having connection table information available here. Now, along with this, let's say show xlate. Okay. Now, so this is where you can do the communication. Also, we can see show NAT detail if you find any information here. So with this, these are our commands what you can use. Show NAT details. show xlate, show connection table. So these all are you can communicate with. Followed? Any doubt in static NAT? Yes, no. Good to go forward? Palmer, Archana, this admin. Okay, good. Okay then. So let's go forward. And now we will be going to do the same dynamic NAT. So here we'll be going to create a pool. So let's first remove the configuration what we had. To remove configuration, we already learned. Command is what? Clear, configure, object. So it will be saying unable to do this because why? NATing is already there. So first remove NAT and object. Okay. So now verify. Show NAT, NAT detail, show xlate. There is no information available. Show conn, no, right? So now again we'll do the dynamic NAT configuration. Static NAT we understood, now dynamic NAT. So for dynamic NAT also we require two objects. So let's do this. So to create object, command is what? Object network. Similar way we'll be using. One is your public IP and one is your private IP. Now public IP will be having a range of IP, let's say 150.1.1.1 to your, so you have to use first range here. So public, you'll be going with range 150.1.1.1.1 and see what it is saying, end IP. So it is 150.1.1. Say 10, 20, whichever range you want to take. So I'll go with 10. So once this is done, you can go out, create object again, object network. Now this time it is private address. So private hyphen IP. And now here you can specify a whole subnet. Let's say for all devices I want to do, so everybody will communicate, right? So subnet only I'll specify. Now what is my subnet? So you have to specify the subnet range. So we are currently using 10.1.1.0 network and you have to use mask here. 255.255.255.0. If this is the case with respect to router, it will be wildcard bits, but on ASA it is subnet mask. Okay. So hit enter now and done. Come out and see. Now you can verify here with show NAT details. So now NAT is not configured. So let's say show run objects. And these are what objects we configured. Now, two way you can do this within your object and outside also. So first I'll show you the outside one and then we'll go for inside one. Okay. So same configuration will do. I'll just copy this configuration here. So I'll just rerun this later. Now, NAT, we have to specify it inside, outside. How we are doing this? See, we have to use a source. And now source is what? Static or dynamic? It is dynamic. And now you have to specify the object name. So we'll be using what? Public pool. Correct? So dynamically you can directly say public IP. And we are going for what? Subnet, no? Public private IP to public IP. Show NAT, show run NAT. This is what we used. Now show NAT details. Now see, understand what it is saying. It is saying that you are going from inside to outside. You will be having origin that is 10.1.1. network, which is 24. Will be going to translate your address from this ranges. So currently we don't have any information. So if you give xlate also, there will be no information visible, right? This is for 10.1.1 to who? 10.1.1.6. Now let's try with the connection. This is why it is showing. So let's call show xlate and show connection table. And now we'll see the ping and we'll verify. Okay, so see now how we'll be verifying it. So show NAT details will give us the net details that is working here. Now go on your router 1, generate the request and go on your system here and verify. System is gone. Go with privilege 15 and see who access now. 50.1.1.6. Previously it was 1. So from that pool it is selected 6. Now along with that, let's generate traffic from router 2 as well. See, both the system are generated the traffic. Now here 1 and 6 is currently being used. It is totally random. So if you see, the IP will be using how? Now it is done. See, 1 and 6. So currently 2 systems are generating. So 1 and 6. So let me do one thing. So currently this traffic is also currently going on here. So let me stop this. And call it again here. And let's verify again on router. Correct. From the same pool, it is selecting the IPs now. And now here again, if you start another request, and this will verify here. Let's rerun this. So this request stops. So again, it is using 6. So from that pool, it will be using the IPs. So let's go forward now. And if you want to see the result on this router, we can also set up a debug here. Do debug IP ICMP. So here also you can verify those information. See, From 6, you are responding to the 6. Now let's generate the traffic from router 1, which is stopped. This request will generate here. And now verify it on router 1. So here you can see 1, 3, 6. So 3, 6, 10. Here it is visible. Sometime what happen, your HTTP request do not pull this information quick. So you will be not able to see, but as debug command, if you give, you will be able to see each and every packets there. So if you see here now 3, 10, 6, 1, these all our IP addresses are used by the system to translate it and how the communication outside. This is called dynamic NAT. Okay, so this is what we done inside. So now outside, now let's do from the inside. So to do from inside, let me just clear configuration, what we done for NAT. Object will keep it as it is, but I'll go to the object, or let me clear the object again. So we'll not have any confusion only. Okay, so see now how we'll be going to do. This much clear, guys? Here, any doubt? Yes, Viraj, Hariprasad, admin, Archana. Good, right? Okay, then. Yeah, if you don't follow anything, you can let me know. So we will discuss it. So here, so far it is manual NAT. Now let's go for your object creation. So object network, call public first. Let me call it like public -IP. And for public IP, we'll be having a, you can say a whole range, or you can go with a single host also. Okay, so I'll go with the range only. So range is what? This time I'll change the address to 140.1.1.1.1 to 140.1.1.1. Let's say very precise, we'll go how many devices we are having? 3, so I'll go with 6. Come out, object network, now private IP. Now from private IP, we'll be going to do subnetting for whole subnet. Now subnet is who? You have to specify the subnet, which is 1.1.1.0, and you have to specify the mask, which is /24. And inside only here you can use NAT. See, now inside your private address only you can call NAT now, and you can say inside, outside. How we'll be going to do this? We'll be going to do dynamically. And what you will be going to use now? Public, the IP what we have used. So public pool. So what we have used, let's verify again. So this is private and the name is public-IP. So we have to use the same exact, otherwise it will not work. Okay, done. Just hit enter and verify now. Show NAT details. Can you see? Now this will considered as what? Auto NAT. Previously we done that is manual NAT. Now this will considered as auto NAT. And you will be able to see information here. From this whole subnet, you will be going to translate your network here. Correct? Followed? And now we will verify this. So from system 1, system 2, and from this system, it is constantly going already. So verify HTTP server is giving us information or not. So see here 140.1.6. So this is not always it is giving you the exact information. It's not fetching out all this information very quickly. But if you go on router 1, you will be able to see all the response also. So come down. This is very up. Here it is. Now, can you see here? You are using 1.3, 1.2, 323232 you are using, and somewhere we'll be using 1. So 1, 2, 3, 1, 2, 3. 3 system we generated. So 3 system you will be able to see the responses. Followed? This is what you can do from outside and inside both. Any doubt? So here somewhere we are using 140.1.1.6. So let me stop this from this system because it's constantly going. So this is called your dynamic NAT. Now we'll go for dynamic PAT. Dynamic PAT can do with both things, which is your both object and single object. You can create with single object also, and you can create with both the object also. Okay. So let's see this information now. So along with this on router, we'll verify a couple of things. If we say show xlate, see, these all are entries what you saw here. And this timed out will be what? This NAT information, what you're using currently, which will be stay for 3 hours here. Okay. So this entry will remove after 3 hours. So flags and all, if you understand, here is the flags. Okay. Now, after your xlate table, you can say show NAT detail to get the detail information about this. So NAT is done, xlate is done, show connection table. Now let's generate traffic and then again we'll verify the connection table. See, connection table, if you do, it will only here, like if you only registered when you re-triggered it. Okay. So this is what you're having as a connection table, which is up. Okay. U flag is for up. Followed? Any doubts here? So we can go forward and do the dynamic PAT. Clear? Okay, good to go then. So let's remove all this configuration here. Let's say clear configuration for NAT and objects. Done. Now we'll do for dynamic PAT. Now how dynamic PAT is getting done? See here. For dynamic PAT, again, we'll be going to create your object, network. Let's say network, we are using here a public one, public IP. With static IP, we are doing this dynamic. Okay. So we are doing dynamic PAT for static IP with 2 objects. So host, let's say we'll be going to do for our host. So public address will be, this is public address, right? Let's call 100.1.1.1 exit object network. This is object for network, and you can use the private IP and specify whole subnet here, which we want to do for 10.1.1.0/255.255.255.0. And once this is done, do the NATing configuration here only. So as we already learned it, inside, outside, we have to do dynamic for what? public. So you have to use the address with like object name which we have created, public hyphen IP, correct? And that's it. Now show NAT details, and here you will be able to see 10.1.1 is getting translated into 10.1.1.1 outside. Now similar way you can say show xlate table, and you will be able to see the NATing information here once you triggered it. Currently it's not. So let's trigger it and verify it. Let's go down. Still we are having 140.1.1.1. ICMP has not renewed or what? Clear configure NAT object show NAT show xlate. So this entry should be removed. Done. Now do it again. Object network. Let's call here public IP, which we have already decided IP, which public will be using, that is call it host 100.1.1.1.1. Here only I'll just write this. Also you can do object network. Inside this again you can create another one which is for public one. So let's call public is done. No, we are doing for private hyphen IP, and can specify the whole subnet which you want to convert. So you will be using 10.1.1.0 to 55.255.255.0, and then we can say NAT inside, outside. Then you can specify dynamically we'll be doing this for static for one IP, which is a static IP. Then we are using what? Public IP. So show NAT details. And now it is translating here into 100.1.1.1. Similar way, show xlate table. Translation is here. Will not show here because we are using dynamic. Until and unless it trigger, it will not showcase. So once it triggered, then you can see entry will be visible here. And this entry is for only 30 seconds for your dynamic pattern. So here your timing will be able to see, and now you'll be seeing here, this is auto NAT and ICMP entry will be for 30. And now verify your HTTP request will go for how much? I can directly give you the number, but we'll verify here. And now see, TCP is going for what? 30. ICMP 30. So now we'll verify on router 1. What is your identity? See, 100.1.1.1. Both the way you will be having this communication with the same IP. Correct? So this is what dynamic PAT with two objects. Okay. Now we can do the dynamic PAT with single object also. So that we'll do on ASA now. So let's do exit clear object, sorry, configure object. Clear NAT clear xlate, show NAT detail, and show xlate. No entries? Good. So now go for your dynamic PAT static with single object now. So how to do this? Very. So again, we'll be creating the object. So let's say object for network. What is our network? So let's call a private network we'll be doing for now, correct? So inside private object only, we'll be going to specify a whole subnet, which is 10.1.1.0 slash 255.255.255.0. Once you specify that, here only go with the NAT. This also you can do inside space. Oh, not NAT. Inside, outside, and now dynamic. We are doing everything for what? Dynamic. And now see here, you can also specify the address. Mapped one address. Instead of mapping object, we done with what? We done with object now previously. Now we are doing with this IP. And also you can do with interface. So this interface you already understood. Like I showed you with packet tracer, right? How we do with the interface. Similar way here you will be able to do with the interface. Okay. So that also I'll show you now. After this, we'll do interface and then we'll go for your static part. Okay. Now, so let's see how to do this. So currently we'll be going to map. So let's currently map with address. Let's take a different address now this time. Instead of 100, now we'll take 200.22.1.1. This address what we map. So show NAT details. So this is what you will be translating. It's showing, no problem. Then show translation table. Currently it will not show you. Show connection table, which will not show you. So now let's generate the traffic and verify here. Done. Like here we can see now it is PAT. Can you see ICMP PAT and NAT detail? So this is auto NAT. So this is PAT. It's showing auto NAT, but it is PAT now. So when we show this with xlate table, so translation is happening with what? PAT, port numbers. Okay. So here you will be able to see this. These are our port number now inside your xlate table. So we can verify this information on your router here. A number you are receiving here, that should be 200 dot this number, correct? And along with this, let me see undebug all debug IP packet details. Just to verify things, let me just check the whole packet. Okay, that's it. Let me go back. Okay. Now verify here. We already verified it. Show xlate table. And here is a PAT translation. This is how we can do with the one object also. So one object translation, two object we also done. Now let's do with the outside interface. So, well, let's quickly do this. Now let's say clear configure object and call this for natting also. NAT Clear xlate table also. Done. Show NAT, no DAT. So good. So let's say how we'll be going to do for interface. Now for interface, similar, you can just create one object and instead of specifying the address, specify the interface now. So I'll be calling here object for network for private IP. First specify the object. Let's specify the whole subnet only. So 10.1.1.0 0 255.255.255.0 and do NAT here only. So NAT not net NAT inside, outside, and dynamic. Now specify the interface, and that's it. Okay. And now see here, show NAT details. What is your ID here? Outside, your identity will be 11.1.1.10, and this is nothing but your exiting out interface. So when you will be going out from your internal network to the outside network, your identity will be switched over to the interface identity here. And this is how your actual router also do. Internal inside your house, you'll be having multiple devices, but router's identity is the identity for all the devices. Router do ports here, like segregating your network with respect to port here at router only. Similar ASC will be doing the same. Now everybody is having different identity, but when they will be going out, they will be going with the same address here. With the port number, they will be able to differentiate. So if you see, let's enter the traffic and verify it's translated or not. So here you'll be able to see 11.1.1.10, it's done. And here also you can verify. Show translate table here, correct? And now show NAT details. So here you can verify. So what it is? It is ICMP PAT. Now you can verify here. Those are all things. So flag is stating what? RI. Now what does R mean? R is port map. Okay. Port or map. And I means dynamically map. So it's a dynamic port map. So here you can specify, like here you can read inside your xlate table, you can read these flags and you can understand how it is happening. So we already done this. So identity NAT, dynamic NAT, roadmap, static twice, which is already done. Okay. So this is one way to do this. Now rest we'll discuss it next session. So next session we'll go and we'll discuss your destination NAT and policy NAT. So how we can have separate identity for separate networks. So let's say this router want to go and access this router with a specific IP. So let's say something like 1.2.2. something, and this router if want to go and access this one, it should go with let's say 3.3.3.1. So this is called policy NAT. So how separate NATing can be done. So that we'll be discussing in your next session. Okay, clear? Any doubts? Let me stop the recording.